Somewhere along the equator, in the middle of the Pacific, there is a stretch of open ocean that looks like nothing at all from the deck of a ship. Blue water to the horizon, the same in every direction, no coastline, no landmark, nothing to tell 1 square mile from the next. Yet every few years, the temperature of that water shifts by just a degree or two, warmer or cooler than usual. And when it does, the weather changes on every continent on Earth. Rain that should soak one side of the planet falls on the other instead. Forests that should be dripping wet dry out and burn. Deserts turn green. A fishing crew in Peru, a wheat farmer in Australia, and a family waiting on the monsoon in India all feel the same invisible hand, and all of it traces back to that one ordinary-looking patch of sea. To my mind, it is the closest thing our whole planet has to a heartbeat. Right now, in 2026, that heartbeat is building toward one of its biggest beats in 40 years. Over the next few minutes, I want to take you down into how a single piece of ocean can quietly run the weather for billions of people. Why the first humans to notice it were fishermen who simply thought a warm current came at Christmas, and how a swing of 2 degrees becomes drought on one continent and floods on another. This is not really a story about a storm or a season. It is a story about a rhythm older than any of us, one we have lived inside our entire lives without ever feeling its pulse. Start where it was first noticed, because the people who found it were not scientists. For centuries, fishermen along the coast of Peru and Ecuador worked some of the richest waters on the planet. Cold currents there rise up from the deep and carry nutrients to the surface. And where the nutrients go, the fish follow, in numbers that built whole towns. Yet those fishermen knew that once in a while, usually around the end of December, the sea would betray them. Their water would turn unusually warm. Whole shoals of fish would simply vanish, as if the ocean had been switched off. With nothing to catch, the men would haul their boats up the beach, mend their nets, and wait it out with their families. Because the warmth arrived near Christmas, they gave it a gentle, almost tender name. They called it El Niño, the child, after the Christ child. They had no idea they had just named one of the most powerful forces in the natural world. For a long time, that was all it was, a local quirk of one coastline, a few bad fishing seasons that came and went. One letter from Peru in 1891 marveled that during one of these warm spells, the deserts turned green and strange fish appeared that no one had seen before. But nobody connected it to anything larger. It took most of another century before anyone realized that the fishermen had their fingers on the pulse of the entire planet. The next clue came from the other half of the story, the air. Back in the 1920s, a British mathematician named Gilbert Walker, handed the thankless job of predicting when the Indian monsoon would fail, went digging through decades of weather records from stations scattered around the world. He found something that should not have been there. Whenever the air pressure ran high over the eastern Pacific near Tahiti, it ran reliably low over the western Pacific near Australia, and a few months after the pressure tilted one way, the monsoon would stumble. Across the tropics, the whole atmosphere seemed to rock back and forth like a colossal seesaw, one side rising as the other fell. Walker named it the Southern Oscillation, and he could not say what drove it. He was reading the sky. The fishermen had been reading the sea. 40 years would pass before a Norwegian named Jacob Bjerknes finally set the two halves side by side and saw they were one machine. El Niño's warm current and the atmospheric seesaw of the Southern Oscillation were not two phenomena at all. They were the ocean and the air leaning on each other, locked in a single coupled rhythm. We bolted their names together into one word, ENSO. So what is actually happening out there? Picture the Pacific as the largest body of water on Earth, a basin so wide it covers a third of the globe. Across its equator, steady winds called the trade winds blow from east to west, day after day, year after year. Those winds do something simple and enormous. Hour after hour, they drag the warm surface water along with them, piling it up on the western side of the ocean, over near Indonesia and Australia. Think of slowly dragging your hand across a full bathtub. Water heaps up at the far end. In the Pacific, that heap of warm water sits so high that the sea near Indonesia is normally about half a meter taller than the sea near South America. Because all that warm water gets pushed away from the Americas, cold water rises up from below to replace it along the coast of Peru. This cold upwelling is what feeds the fish. Now here is the part that turns a current into a heartbeat. Everything balances on those trade winds, and the winds are not perfectly steady. Every few years, they slacken. When they do, the great heap of warm water in the west is suddenly free, and it comes sliding back east across the entire ocean like water sloshing back across that tilted bath. Warm water floods toward South America. The cold upwelling is smothered. The fish disappear, and the warmth of the surface starts to leak its heat into the sky above. That is El Niño, the warm beat. Then, often, the system overcorrects. Back come the trade winds, roaring stronger than before, shoving the warm water hard into the west again, dragging up even colder water in the east. There you have the cool beat, and it carries its own name. That fisherman's child, it turns out, has a sister, La Niña, the girl. Warm beat, cool beat, every 2 to 7 years, the largest swing in our planet's climate after the turning of the seasons themselves. Crucially, that slosh back across the ocean is not instant either. Instead, the warm water travels as a slow underwater swell, a wave so broad and gentle that a ship could float right over it and feel nothing, taking months to cross from one side of the Pacific to the other. Strange as it sounds, that sluggishness is a gift, because it means the beat can be seen coming. Strung right across the equator today is a line of moored buoys, bobbing alone in open water thousands of kilometers from any coast, each one measuring the temperature down through the depths and beaming it home by satellite. Those buoys are, in a very literal sense, our fingers laid on the same pulse the fishermen first felt. Except now we can sense the next beat building while it is still half an ocean away. To grasp why a mere 2 degrees can do so much, remember what water really is. Water is a staggering reservoir of heat. Just the top few meters of the tropical Pacific hold more energy than the entire atmosphere wrapped around the whole planet. So when that warm pool spreads east and surrenders even a thin skim of its warmth to the air, it is no small handout. This is the ocean passing the sky a fortune, and the sky spends every cent of it on storms. There, really, is why a couple of degrees out at sea can starve a monsoon a continent away. Such temperatures sound gentle. Underneath them, the energy is colossal. What still amazes me is not that the ocean does this. More striking is how far the consequences travel. Because the ocean does not act alone. When that patch of equatorial water warms during El Niño, it warms the air directly above it, and warm rising air is the engine that drives rainfall. Earth's zone of heaviest tropical storms, which normally sits over the warm pool in the west, gets dragged thousands of kilometers east out into the open Pacific. Once you move the planet's biggest rain factory, everything downstream of it moves too. Our atmosphere is not a set of separate weather systems sitting politely over each country. In truth, it behaves as one connected fluid, and a shove in the middle of the Pacific ripples out through the whole thing. Scientists even have a word for these long-distance links: teleconnections, from the Greek for far away, because a change here reaches out and touches the weather there, half a world apart. Follow those ripples, and the scale of it becomes almost hard to believe. During a strong El Niño, the monsoon that hundreds of millions of people in India and Southeast Asia depend on tends to weaken, and the rains that feed the crops arrive thin or late. Southeast Australia dries out, and the bush turns to tinder. Indonesia's rainforests, normally far too wet to burn, dry just enough that fire can take hold. Meanwhile, on the other side of the ocean, the script flips. Coastal Peru, home to some of the driest deserts on Earth, can be hit by torrential rain and flooding. Parts of the southern United States turn wetter and stormier. The dry season in East Africa can drown. One study found that the total area of the tropics gripped by drought can more than double during a strong El Niño. When the cool sister La Niña takes over, much of it inverts. Floods return to Australia and Asia. Drought creeps back over the Americas, and roughly a third of the world's land can see its yearly floods intensify. One patch of sea, a couple of degrees, and the rain maps of entire continents are quietly redrawn. Its reach even bends the hurricane season in a different ocean entirely. During El Niño, the shifted winds high over the Atlantic tend to lean across the tops of growing storms and tear them apart before they can organize. So a strong El Niño year often brings a calmer Atlantic hurricane season. When the cool sister takes the stage, that shearing wind relaxes and the door swings open again. One warm anomaly in the heart of the Pacific, quietly settling the storms of a sea on the other side of the planet. Once you start pulling on these threads, it becomes genuinely difficult to find a corner of the globe the Pacific does not, in some season, reach. If that sounds like a force from the distant past, it is not. We have watched it happen twice in living memory, and both times it rewrote a year of the world. In 1982 and 1983, a powerful El Niño brought drought to Africa, Indonesia, and Australia, and flooding to South America. And at the time, hardly anyone saw it coming. Then came the big one. That El Niño of 1997 and 1998 is still regarded as the most powerful on record. In one stride, it pushed the average temperature of the entire planet's air up by around 1.5 degrees, when a normal El Niño nudges it by a fraction of that. Floods swept the Americas and the Horn of Africa. Drought gripped Southeast Asia. Fire took the forests, and the seas warmed so severely that an estimated 16% of the world's coral reefs were bleached and lost. Worldwide, the damage ran into the trillions. All of it set in motion by that same quiet stretch of equatorial water, breathing out a single enormous warm beat. The most recent superbeat in 2015 and 2016 helped shove global temperatures to record highs and pulled the rains away from southern Africa, leaving harvests to wither across a whole region. 5 times now, in the span of a single human lifetime, the Pacific has exhaled hard enough to be felt in every hemisphere. And that brings us to now. Through 2026, the forecasters have been watching the Pacific tip back into its warm phase, and what they are seeing has their full attention. Forecasters now give this El Niño around a 90% chance of reaching at least strong intensity, and better than a 60% chance of crossing into what some call a super El Niño, with the central Pacific running more than 2 degrees above normal by the heart of winter. A few of the model runs push it past 2.5, into territory that would put it among the strongest events ever measured. To put that in perspective, only 5 super El Niños have struck since 1950. 11 years have passed since the last. Our planet appears to be winding up for one of its largest beats in a generation, and unlike the fishermen of old, this time we can see it coming months in advance. There is something bigger hiding inside all of this, beyond any single flood or fire. Follow the threads far enough, and they nearly all run back to the same place. And the planet slowly stops looking like a patchwork of separate climates and begins to look like one connected body. A shift in the temperature of the water off Peru is felt by a farmer in Africa who will never once see that ocean. Such a system holds no respect for borders or maps. It behaves like a single living thing with a slow, powerful rhythm, and every one of us is living somewhere inside one of its beats all the time, whether we notice it or not. The thing I find almost moving in all of this, honestly, is the humility folded into that first name. Fishermen with wooden boats and no instruments felt a warm current arrive near Christmas, watched their fish vanish, and reached for the gentlest word they had: a child. Those fishermen were closer to the truth than they could possibly have known, because they were the first to put a hand on the pulse of the planet, even if they only ever felt the faintest edge of it. Everything we have learned since, the satellites and the buoys strung across the Pacific, and the forecasts that now reach months ahead, is really just us slowly learning to read the same heartbeat they first noticed in the disappearance of their catch. We like to imagine weather as something local and personal. Your sky, your week, the little forecast on your phone. Yet trace any odd season far enough back, an autumn that refuses to cool, a drought that overstays its welcome, a year of rain that never quite lets up, and the thread will often run thousands of kilometers out to the temperature of an open ocean you will never lay eyes on. For nearly all of human history, we only ever brushed the faintest edge of that rhythm, in a catch of fish that failed to come in around Christmas. Now the warm beat is rising again toward something the planet has not felt in over a decade, and for the first time we can watch it gather from months away. All the while, the Pacific is doing what it has always done, breathing slow and deep, indifferent to our maps and our calendars. Only one thing has changed: us. At long last, we have learned to feel its pulse before it reaches us.